In this video, we're going to be simplifying with rational exponents. So we're going to take a look at our first problem here. We have negative 32 raised to the negative 4/5 power. So here we have our power, which is our 4, and we have our index, or the type of root, which is our 5. And we know that because it's in the denominator. Now we are going to take the negative with our numerator as the power, because we have properties that help us deal with those. So we're going to rewrite this now in radical form. So we're going to take our negative 32, or our base, and we're going to put that inside. Now remember that our index goes inside and gets squished by the little radical house, and then our exponent is going to get to come outside. And we could have written it on the inside, but our properties let us just pull it out. And so now we're going to try and simplify this. So the 5th root, because it is an odd root, it's okay that we have a negative sign inside. So the 5th root of negative 32 is a negative 2, which gives us negative 2 raised to the negative 4th power. Now because our 4 is negative, we need to rewrite this, because if we have a negative, we can't let it stay. So because it's a whole number, we're on a numerator, we're going to switch it to the denominator. So this is going to give us, we'll move this over here so we have some room. This is going to give us 1 over our negative 2, except this time it's going to be raised to a positive 4 power. And then from there, we can get our answer of 1 over 16. And we have a simplified answer. Let's take a look at letter B. So here we have negative 5x to the raised to the 5/3 and 3x raised to the negative 3/4. And if we look at this, our base of negative 5 does not have an exponent, and our base of 3 also does not have an exponent. So we can multiply those together to give us a negative 15. And that's going to leave us with x raised to the 5/3 and x raised to the negative 3/4. Now here we see that we have two bases that are the same, which means that we are allowed to take our exponents and we get to add them. So now we have a negative 15 times x raised to the 11/12. And we got the 11/12 by adding our exponents together. And so we see that we have a simplified answer here and no negative exponents. And so we're done. It is important to note, though, that x cannot equal 0. So that's going to be part of our answer as well. So let's take a look at our third example. Here we have the cubed root of the square root of 125. So remember that that is a square root. So even though the number is not there, that is a 2. And so from our properties of radicals, we know that when we have a radical inside of a radical, we are able to multiply those two radicals together. So what we really have here is the 6th root of 125. So now we're going to kind of break this down a little bit, and we know that we have 5 times 25, and that the 25 breaks down into a 5 and a 5. Okay. And so here we see that we have 3 5s. So we can rewrite this again as the 6th root of 5 to the 3rd power. Then we're going to go ahead and rewrite this back with our fractions, which gives us the 5 raised to the 3/6. And we can reduce the fraction 3/6, which is going to give us a 5 to the 1/2 power, which can be rewritten again as the square root of 5, which is going to be our final answer because we can't simplify that any farther. And depending on your teacher or what kind of math you're doing, you also could probably leave this as the form 5 to the 1/2 as well. It just kind of depends. So let's look at our last example. So here we see that we have 2x minus 1 raised to the 4/3 and 2x minus 1 raised to the negative 1/3. Now this looks like it's going to be a really hard problem, but it's not. Here we see that we have our bases of 2x minus 1, and those are bases because they are surrounded by parentheses. So all of that is the base. And so when our bases match and they're side by side like that, we are able to take the exponents and add them. So we're going to have a 2x minus 1 raised to the 4/3 plus negative 1/3, which is going to simplify into 2x minus 1 raised to the 3/3, which is just the 1 power. So we don't need to write that down. So here we have it simplified, but x is not allowed to equal 1/2. And this is our simplified answer, all of it. So how come I know that x can't equal 1/2? Well, let's talk about that. If I plugged 1/2 into this equation that has the negative exponent, the negative rational exponent, I wouldn't have a good answer. I'd have 2 times 1/2 minus 1 raised to the negative 1/3, which would come out as a 0 to the negative 1/3 power. But that's not a real number. And so we don't have a defined place when x equals 1/2. And that's why x is not allowed to equal 1/2.